we can see your first slide, no problems. And it is on the hour. So everyone, this is Kate Smith with Cardinality Estimation, Comprehensive Look. Off you go, Kate.
Okay, great. Thank you so much, Andrew. So yeah, my name is Kate Smith. I'm a PM at Microsoft, and my pronouns are she, her. I've worked in the space of query processing in various roles for like a decade now. And so I'm going to go and give a comprehensive look of cardinality estimation in SQL Server. So I'm gonna sort of give you some history and build up to sort of where we are today. And I'm gonna sort of try and tell a story about how we got from, cardinality estimation, what it was, 15 years ago, to cardinality estimation that we have today, and the new features coming out in SQL 22 around cardinality estimation feedback. My goal is not to melt your brains, I'm sorry, but to actually build some understanding and some intuition about the concepts. A lot of you have heard these words flying around a little bit if you've been paying attention to the SQL 22 announcements and stuff like that. So I want to sort of build a deeper understanding. Okay, so next slide. Sorry. So a little history. Cardinality estimation. When I joined SQL Server, there was a project that was ongoing to rewrite the cardinality estimation module. So cardinality estimation is basically the part of the query optimizer that looks at a particular expression or expression tree and estimates its cardinality, or the number of rows that would come out of it. And as it was existing in the product at that time, the code was hard to maintain. So we were getting bugs and requests for change and things like that from internal, external, and it was becoming very difficult to maintain the code. So the original effort was to rewrite that module in such a way that would be easier to maintain and address issues moving forward. So we did that. What was interesting is, so cardinality estimation uses something called a model, which is a basic set of assumptions that we need to make about the structure of the data in order to move forward. And you'll get a more intuitive sense of what I mean when I say the model as I go through my talk. So don't worry if it's a little weird right now, it will make sense. And that original model had three basic assumptions. We called them independence, uniformity, and containment. Now, we rewrote the cardinality estimation module, and we hewed back to that original set of assumptions. And when we ran it on real customer workloads to see, well, how does this perform compared to the cardinality estimator we had before, we found that it actually didn't produce better plans. That by going back to that original model and adhering to it more strictly, without all the little changes and tweaks that had evolved over time, turns out that model had deviated. And so now we were in a situation where we had to figure out what model would make sense given this information. So we had some very talented, experienced, in the problem space and mathematically minded devs on the team at the time. And so they said, well, here's some variations that we could try. We could try changing this assumption this way or changing that assumption that way. And they implemented a whole bunch of different options around model variance. And then we reran a whole bunch of workloads as much as we could to see which performed best across the majority of them. And it was tough because we still had to pick one set of assumptions, one model to go from to start. We couldn't just say, we still had to have one baseline, right? We couldn't have multiple different models existing at one time. So, but that laid the groundwork, as you'll learn, for what's coming next in SQL 22. So Before 2012, we had this assumption of uniformity, independence, and containment. That's what we perceived our CE model to be, although it wasn't quite accurate when we actually reran the tests. But we didn't really know what had been changed. We just knew that changes had been made that made workloads better, right? So then we came and redid this cardinality estimation model, and we still had to pick some assumptions. We picked uniformity, partial independence, or exponential backoff, if you've heard that, and a different take on the containment assumption with regards to joins. You'll understand that better later too. But CE feedback, which is coming out as part of the intelligent query processing improvements coming in SQL 22, changes all of that. It diverges completely from this one-size-fits-all model. Now, for every query, not just every workload, but every query, you can choose, well, you don't choose. Actually, that's the cool part, is we can try. Well, for this query, maybe this model variation would work better. And for this query, maybe this one. And we could automatically test that out, decide if it really is better, and then encapsulate that using Query Store in such a way that you don't even have to change your code, and you get a different model that fits your query better on a per query basis, which is super cool. Okay, so now I'm going to dive into this concept of uniformity. So we're going to have some look at statistics. Those are the building blocks of cardinality estimation, right? So underneath cardinality estimation, there is statistical data about the columns and tables in your database. And if you've ever done a DBCC, show statistics with histogram query, you would get a response that looks like this. It's got sort of these different columns, right? High key, range rows, EQ rows, distinct range rows, and average range rows, which is derived from range rows and distinct range rows. And I'll explain that. So here's a picture of a histogram, okay? So the black lines, vertical black lines, correspond to those EQ rows. Those are heavy hitters, data values in your column that are at a high frequency. And so we give them their own information. We create a histogram step and we make that the EQ rows value. And then that range rows, range high key is, and then EQ rows is the number of values corresponding to that high key in the column. Then you can see here in our picture, you've got these column values that are sort of the in between those black lines, the red dotted lines, and those are the other values that actually appear in the data. But instead of keeping track of each individual value, we put them into that bucket. That's the space between the two black rows. And within that bucket, we keep track of the number of rows that we've seen in total between those two, in that bucket, and the number of distinct values that we've seen in that bucket. And we can use that to compute the average value for anything in that bucket we just assume an average across that it's flat, even though you can see from the data it's not. That's what we do. So because the alternative would be to keep every single data point again in the statistics, which I don't know how useful that would be. At some point you have too many steps. So so that average range rows is where this uniformity assumption comes in. We assume that all of those distinct values in that bucket are evenly spaced and that they all have the same frequency. Again, average range rows. So within each histogram step, those distinct values, we know that they're not actually evenly spread in most real world data, but we assume that. And each value has the same frequency. They all occur at that same average range rows occurrence. So let's give an example here. So here is, we want to estimate the selectivity of a column equals constant predicate. Select star from T, where T.C1 equals 50. So you see our picture down below. We've got a bucket boundary at 58 and a bucket boundary at 29. So 50 is going to fall somewhere in the middle there, right? We assume, okay, that 50 exists in the histogram bucket. It may not actually really be there, but the assumption that's built into our model is that it is there. That is a take on the containment assumption that if you query for it, it is there. And that part of the containment assumption still holds in SQL Server today. It is only with joins that we've changed it, and we'll talk about that later in the talk. But we also assume that the frequency of value 50, meaning how many values are in there, is the average frequency of the bucket, that where that green area is. That's the number of 50s that we would say there are, because it's within that bucket boundary. So that's how we use uniformity today in SQL Server when we interpret our histograms. So let's talk about CE feedback, uniformity, and row goal. So this is part of SQL 22. So row goal is a feature that can apply to queries of type select top n star or fast n or in or exists. Okay, so these types of queries, we would want to know how many rows do we need to read to get the top n of this value, right? And we want to optimize the query so that we can read as few rows as possible to get the result that's requested. So if there's a large percentage of rows that match that predicate, then maybe we don't need to scan that many pages. We can just do a table scan and we'll find that very quickly, right? If the data is not uniformly distributed, what could happen is that even though we think we might just need to look at a couple, the data might be spiky and might be in a different place in the index. And we might have to scan a lot more pages than we originally thought. And therefore, that row goal operation was inefficient. So CE feedback can disable the row goal scan and enable a seek so that we would just get that, that specific seek to the values that match what we're doing top n on. So let's move to a demo, unless there are questions.
Yes, so there's a couple of questions. So can you pin a CE path in Query Store in 2022, much like pinning a plan?
Yes, yes, I think you can. And we'll talk about that. You would use Query Store hints to do that, and I'll show you how it works. I'm going to show you right now how that works. Yeah.
One more question. This person thinks that they have 200 steps in a histogram, and they don't think there can be too many more. Is that different in 2022?
No, we have not changed the underlying histogram structure.
Okay.
It's still 200.
Good. That's all we had so far.
Okay, sounds good. All right, let's bring up the demo here. Okay, I'm just hoping you can all see just fine. Can everyone see? Yes, 3. Okay.
Yes,
right.
sorry, I was muted. Yes.
No, it's fine. I just want to make sure. So I'm just going to set up my environment here. I'm using AdventureWorks 2016. And I'm doing a bunch of stuff to like set up Query Store and whatever. And then we're going to clear the plan cache and drop the buffers. And then we're going to create an X event session. This isn't really interesting. I'm just showing you that this is what I'm doing. And then we'll start the X event session. Right. Start. Okay. Let me refresh this here. There we go. All right. And then we'll go ahead and we'll select watch live data. And I'm going to just put it over here off to the side right now. Nope, that's not what I wanted. There we go. Put it off to the side right now, and we'll see, we'll drill in on that as events show up. So here I have a query that shows I'm basically selecting that top 1500 from sales order header joining sales order detail with a filter on the date. And we're gonna run it a couple of times for CE feedback to say, this query is one that we do indeed want to start analyzing. If the query isn't run very frequently, it doesn't make sense to trigger analysis on it, because we wouldn't want to analyze every ad hoc query that comes through. We want to make sure that it's a consistently run query so that we're not working too hard for very little benefit, right? And then we'll flush that information to the query store, make sure that that's flushed. And we can look at the plan that we got here. Let's come over here and look at our query plan. That would be the wrong one that I clicked. Hold on. Why did I not run it? Sorry. This is what happens. I'm like, I will do a live demo. Ha ha ha. Okay, well, okay, I guess the plan wasn't there, but it's very frustrating. I'm sorry. All right, let's look at it. So this is the plan that we have now. Okay. I apologize because this was supposed to work and then it didn't show up, and now this is what happens when you do live demos, people. It's dangerous stuff. That's all right. We can still look at what's happening. So we executed the query enough times that CE feedback created this X event that it thinks that it would be better if we disabled optimizer row goal. Okay. And so it says, we think we might try that. Okay. And then you have to execute the query again, and it tries to validate that. What it does when it tries to validate it is it looks at CPU time and compares the CPU times. Okay, and it says, okay, yes, the CPU time in this one was faster than the original, so we're going to disable row goal. And and then once it's disabled, the feedback gets applied, and it's consistently applied. So then we can alter, we can stop our X event session, kill that because we saw our X events, but you can see where they're applied in this table, query store query hints. So with there's a feature coming out for query store hints in SQL 22, where you can apply hints to queries. You can do it as a user, you can specify a hint, or you can actually CE feedback can also put the hint there, and then you can see what, for this query, this is the hint that we're applying. This is the source, so it came from CE feedback. Here, I'll zoom in so you can see that better. And then you can look at what that feedback is. Another place that you can see what's happening is if we look at query store plan feedback. So here you can see CE feedback added this hint and verification passed. So that feedback was verified, and it is now being used, applied to that plan. That's pretty cool. So that is the row goal demo for this feature, for basically how CE feedback works in a way that changes that uniformity assumption a little bit. All right, are there any more questions, Rhea? Are we good?
Oops, hold on, something just popped up. Is query store feedback adding hints part of the auto tuning option that you enabled earlier?
I don't. Oh, you mean when I set up the query store?
That's the extent of the question, but that sounds like a probably.
No, I think it's, you just get this when you have query store enabled and you're running your queries under the right compatibility level. You will just get those the hints, and you will just get. Was the question about the hints or the feedback? Sorry, it was about the hints.
Is the query store feedback adding hints? Is that part of the auto tuning option?
No, I believe that the adding the hints is just part of how CE feedback works. That's the mechanism by which it affects change on your workload.
Okay, perfect. That was the only question, so you're good to go.
Cool. All right. So let's talk about the independence assumption. So, all right. Remember back when you were in college and you took a basic statistics course and you talked about probability and statistics, right? When you've got predicates that are independent, you multiply their probabilities, or the word that we use a lot in cardinality estimation is selectivity. You multiply the probabilities by one another to get the probability of a conjunctive clause. So the probability of P1 and P2, when P1 and P2 are truly independent, is equal to the probability of P1 times the probability of P2. So imagine that you have a database with, and this is obviously a very contrived example, but first coin flip is heads, second coin flip is heads. And the selectivity of both predicates, let's assume it's a fair coin, is the same, 1/2. So the selectivity of that conjunctive clause is 1/2 times 1/2, or 1/4. Quick refresher on independence. All right, similarly, correlation. Take, for example, a data set that has the city of Seattle and the state is Washington. Now, let's assume that there are no data points with the city Seattle and any other state, okay? Let's just, that doesn't exist in our data set. Even if it exists in the real world, it's not in our data set. So the selectivity of P1 is 1/10. The selectivity of P2 is 1/3. In the case of complete correlation, where everything that is in Seattle is also in Washington, you would take that most selective predicate, or min selectivity, and have it be 1/10. So to sort of tie the concepts together, I'm going to contrast that with what independence would give you, which is a probability of 1/30th, or a selectivity of 1/30th. So we're not done, because now we talk about partial correlation, or a concept you may have heard or read about as exponential backup. Here we've got city equals Redmond and state equals Washington, but in our data set, there's also a Redmond, Oregon. So the probability of Redmond might be 1/20th, and of Washington might be 1/3. So with correlation, okay, we know that they're not correlated and they're not independent. So there's something in between here, right? So correlation would give us a probability of 0.05. That's 1/20th, but I translated it to decimal representation so that we could place that more easily when we talk about the partial correlation number. Independence would give us this, 0.1612 number, and then partial correlation, or exponential backup, ranks the predicates in selectivity order. All right, so start with the most selective times the next most selective, but we raise it to the power of 1/2, okay, to weaken the weight of that predicate. If there's a third, we would then weight it to the power of 1/4. It's exponentially backing off the weight of those sequential predicates in that clause. And you can see that this approach gives us a number that's somewhere between 1/20th and 1/60th, and might be a little bit more accurate for the data as it actually appears in this case. So what does CE feedback do? Well, it actually allows us to move in between. We still start at sort of this partial correlation assumption, but we can actually look at the data from the conjunctive clause in reality and say, oh, we overestimated, we underestimated. Let's adjust our independence model for this query appropriately, and so we can move in either direction to sort of adjust to the actual data and the query as it's operating against that data in real time. It's pretty cool. So I'm going to move to a demo, but I'll check in. Ree, are there any questions?
Not right now. You're good.
Okay, sounds good. Okay, row goal is 1. All right, so this is correlation. So I'm gonna use AdventureWorks for this database. I know you have to watch me set it up every time just because I gotta make sure that it's all good to go. We create an X event session. to track what's happening. And then we'll go ahead and start our XEvent session. Select watch live data so we can see what's happening in real time. And then we're going to execute a query. So again, here we are. We're just selecting address information from person.address. That state province ID actually corresponds to Washington State, and city is Redmond. So we can go ahead and run this a number of times. And then we'll flush that data to the query store. And let's have a look at the plan. Oh, good, I have two plans here. That's what we wanted. And so you can see here that our actual number of rows was 121, but we estimated 44. So we underestimated. Underestimate would mean that we're assuming it's more selective than it is in reality. So what's the right assumption to make? If we started in partial correlation, would we move to the full correlation or move to full independence? I'll answer that for you. Actually, I wanted that still open, I think, but the answer is we would move to full correlation. So I know that the example I just talked about in my slides shows that well, we'll see. That is not what I meant to do. I am pushing the wrong buttons here. I'm sorry. I know. All right. Okay, here we are. All right. So here we have, we're going to execute one more time, and CE feedback should wake up and kick in. And you can see over here that we did, in fact, get an XEvent. And the hint that we think might work is this. It says assume minimum selectivity. And what that means is assume that the selectivity of the predicate is the minimum selectivity, is the selectivity of the minimally selective predicate. So if you remember, that corresponds to that completely correlated assumption, right? So let's assume that it's completely correlated and try that. So we go back and we'll execute one more time, and that should validate whether or not this adjustment made any difference. So if we look at the execution plan that we got here, you can see that our actual number of rows was 121, and we estimated 121. So our estimate was exactly right. So that's perfect. The data is completely correlated in this data set. However, if we come over here to the validation XEvent, you can see that the plan hashes, sorry, these are the plan hashes. I didn't expand the column, but these are the plan hashes. The validation plan hash and the original plan hash are the exact same plan. As a result, we didn't actually change the plan. So that original CPU time of 0 basically means the plan hashes are the same. It doesn't matter if this feedback is applied or not. And so even though that's our new CPU time, it still doesn't actually turn out to be better than the old CPU time because the plans didn't change. So in this reality, we don't get any change to the plan. We go back to this one. With the difference between 121 and 44, but remember it's the same plan. And so you can even see here in Query Store hints, no hint was applied. Okay, the feedback ran. It was validated as not being enough of an improvement over what we had before, so it's not worth, you know, basically we aren't going to apply that hint. But you can see in Query Store plan feedback that we did try this hint. We don't have a hint that's currently being applied, and verification regressed. So you can see how CE feedback works in a do no harm way to make your workload run better without without harming how it's actually working. Are there
So I have
questions?
a couple of, yes,
Yep.
yes. So first of all, every time that pops up when you close it and it asks if you want to save, I think it's popping up on my screen and I panic. Like,
Oh.
what did I just do? Like it pops up. No, it's me. I'm an idiot.
Sorry.
Kate. It's
Okay,
fine.
I won't do that.
It's just, it's funny because every single time, like it's not even after the first time I went, oh, hey, no. Okay, so since the question, so since the 44.x row estimate comes from between histogram entries, does CE feedback adjust stats to replace a histogram to match the value equality for that specific query's value? Or is the histogram left alone and CE feedback handles this elsewhere internally?
So it's the latter. CE feedback does not change the underlying on-disk structure of the histogram. And it is because it's also worth noting that this data, I mean, maybe there's a multiple column histogram underlying. I didn't actually look at the underlying statistics objects, although that's a very reasonable question. But it's that conjunctive predicate, right? It's the two. So you can't, unless you're looking at a multi-column histogram, you would still have this question of predicate equals constant and predicate equals other constant. And then that's harder to like look directly into the histogram, if that makes any sense.
Okay,
maybe I
so
confused you more.
I think you did great. Because you ultimately answered his question, right?
Yeah.
So let's see, can you use that hint in your query to tell SQL of known correlations ahead of time?
I don't know. That's a very good question. I know that query store hints is a new feature that you can use to apply hints to your query. Can you do it manually? I will find out, and I will follow up on the Slack channel. If that does that work? Is that the right place?
That works perfect. Thank you. I'll grab the question. You're good to keep going. So
Okay.
What makes SQL Server decide that it needs to improve a plan?
So it looks like CE feedback. Okay, there's a couple of things. One, it has to be a commonly executed query, right? So you know, it has to be not an ad hoc, but a commonly executed query. Two, we need to see a difference between sort of the estimated and actual performance at various points in the plan that we think we can change. So we obviously have implemented some changes that apply to certain situations, but we have not done it all, right? So we look at, you know, in this scenario, do we think we can improve it? And that's basically what we're out to do. So we look at a plan and we say, you know what, we had a conjunctive predicate of two or more predicates, and our estimate was not correct. So we might as well try, and we make that an adjustment in a smart way, right? As I sort of talked you through in the demo.
Okay, then last one for this section.
Mm-hmm.
How does this affect low cardinality estimations from UDFs? Will this allow more accurate rows returned from UDFs to affect a plan's operator choices?
So we do not currently have a UDF specific, I don't know what I want to say, model variant for CE feedback. Not at this time.
Okay, perfect. Okay, you're good to go.
Okay. All right, so let's talk about containment. This is the one that I think is kind of the most confusing. I've seen it presented a couple of times. I had to go back and do some research, but I found a way I think I can explain it so that it makes a little bit more sense. So containment as an assumption, we just use that word broadly, but it means more than one thing. Now, the basic idea, and this is why we use it broadly, is if you query it, it's there, right? So when we look at joins, we assume that things join. When you look at equality predicate, you know, as I showed with the histograms example, you assume that things are there. If it's in a histogram bucket, we assume it's there. In fact, if it falls outside the range of the histogram, we assume it's there because we have to do something. And then when you're probing, so that's that first value. When we're probing histograms with the quality predicates, if you're querying for it, we assume it's there. So that's one meaning of containment. Another one is containment as regarding joins. And there are two different approaches. The names for them, which are not particularly intuitive to me, are base containment and simple containment. So I'm going to spend some time drilling into those two concepts. Cool. So base containment. All right, great. I busted out the relational algebra. All right. So here we've got a join between a sales and a returns table on receipt number. There are two filters on the tables. There's a filter on sales and there's a filter on returns. Now, what base containment does, it doesn't assume there's any correlation between those, that receipt number join predicate and any of the downstream filters. So, but it is reasonable, of course, to assume that every receipt number in the returns table exists in the sales table. That makes sense. You can't return something that you didn't sell in the first place. So, that makes a lot of sense. And that's how base containment works. It assumes that there's a correlation or containment of all returns are contained in sales tables. And then you would calculate that join and then pare down the number of rows based on the filters that are there. So it applies the selectivity of those non-join filters after calculating the join on those base tables. That's base containment. I hope you're not confused yet, because we got more. Oh, sorry, we'll stick with this example real quick. You can see in this example, that makes a lot of sense. But there are other types of things you might be joining that wouldn't make any sense at all, right? Store sales and, I don't know, store locations. There's no reason to assume some sort of correlation. I mean, the join would be different, but you would assume there's no like intuitive containment or correlation, underlying connection between those tables that would make this assumption particularly meaningful a priori, right? So in this scenario, it makes sense, but it doesn't always. So now let's look at simple containment. This assumes that the joins are fully correlated after the filters, okay? So for example, okay, what that means is we're assuming that every that every item that was returned on January 1st, 2013 was a toy. There's like this simple, we do the filter and then we assume that everything, that containment, that sort of matching exists at the join level after doing the filters. And that doesn't really make a lot of sense, but you could think of some examples where it might make sense. Users do know their data pretty well, and they understand what they're doing a lot of times. And so those filters could, in some situations, actually filter out the data so that containment assumption does hold. But, in this example, it doesn't make sense, but you could potentially think of examples where it would be pretty intuitive. All right, so what does CE feedback do? It makes that adjustment. Basically, it's got two containment models to choose from. We start with a baseline of base containment. And then we see if it works, right? So we apply the adjustments only to joins. Again, that containment we talked about with histograms is not touched by this modification that's used in CE feedback. If the estimates coming into the join, right, those rows coming into the join are pretty good, but the estimates coming out are not very good, then it's likely the containment model is wrong. Now, we really have only one option. So if we think that it might be worth trying a different containment model to see if it helps, we try it. Again, you've seen already how CE feedback will try something. And if it doesn't see enough improvement or the type of improvement it's looking for, it will go ahead and turn off its own feedback and say, I'm not actually going to do that anymore because it didn't help the way I was hoping. So I'm going to move to demo, but I do have a chance if there's any questions. Good. Okay.
There are no questions at this time. Sorry.
No,
The mute button is in, the little speaker is in a completely different space than Teams. So I keep.
it's very, I know. Familiar with what you're talking about there, Ree. I'm like, what is this new software? I'm clicking all the wrong things. That's what it feels like. I'm going to go ahead and start. I'm going to close that. I'm using a database, TPCH. I'm using TPCH, the plan cache, etc. Create our X event session. Give it a start there. I'll go ahead and click watch live data. All right, so here we have a query. We're joining customer to orders, where the customer, the market segment is building, and the order date is some date, specific date in 1992, and the customer key is less than a particular value. And then the equality predicate is on that customer key. All right, so we have to run this query a certain number of times for it to be valid for CE feedback. And then let's go ahead and flush that information to the query store. And then let's look at our plan here. So here you see we're doing a seek on each of these tables with a sort there. And our actual number of rows was 7, but we estimated 107. So we estimated that there would be a lot more rows than there were. So it's possible, but sorry, let me go here. Our actual and estimated number of rows for the incoming relationship, that's for the top one, 2,000 versus that 4,000. That's not, I mean, it seems like it's double, but it's not too bad. And on the bottom one, it was 41 versus 160. So let's see, we'll execute the query another time. That should trigger CE feedback thinking, maybe I should try something. So we can come over here and have a look. All right, I'll zoom in here. So this option, this assume full independence for filter estimates, that is basically, we're trying to say, let's use simple containment instead of base containment for this query. So we go ahead, execute it another time. And what you can see is that the CPU time was originally, 5,500, 5,600, and now it's like half, less than half of what it was. So we definitely speeded up the query. I'm going to make this a little bit bigger so we can look at the plan. And that estimate, the estimate going in, that got better. And this estimate going in also got better. And the estimate coming out is a lot closer. I think it was 107 to 7, and now it's 12 to 7. Much, much closer. When you're looking at this as a, planning a query, this might be just a subset of a larger query. It makes a huge difference to see that kind of a small change. Well, it's sort of a big change, but that improvement in accuracy really makes a difference. So we can stop our X event session. And if we look at query store hints, yes, indeed, that option is there. And I'll move this over so that we can look, and you can see that the source was indeed CE feedback. And then you can also see that it is here in the query store plan feedback table. We have using this since it just says independence, but that's what it means, and the verification passed. So yes, it does appear that that adjustment to the query made a difference. Anyway, so that's the demo. I'll pause again for questions in case there are any.
We are good. Let me peek at chat at Slack really quickly, but I think you're caught up.
Okay.
You're good. Okay, yeah, you're good to go.
Awesome. So I'm going to just summarize what I talked about here. CE used to have this one-size-fits-all approach called the model. There really wasn't another way. You had to have one way of trying to approach these estimates. There wasn't an easy mechanism. There wasn't a built-in mechanism to say, well, for this query, let's do it this way, or for this query, let's do it this way, right? We've tried a number of variations over time to try and get that sweet spot where it's pretty good for most everybody, but we know that it's not going to be perfect for everyone. That's sort of, in my opinion, the beauty of working in the query optimizer, because you almost never win across the board. There's always this sort of, you make incremental improvement in one area and you try not to do too much harm in the other area, and you've got to find that right balance. And that makes it an interesting problem space to work in. But with CE feedback, we can now dynamically adjust. We've got, for this query, this model works well, and for this query, this other model works well. We do that in such a way that it's for your individual queries based on what we're experiencing in your workload. And we do it in a do no harm way. As you saw, when we didn't really help, we disabled. We said, no, we actually aren't going to apply feedback to this because it's not helping enough. And by using query store hints, this feedback is going to persist. There's no code change required by you. It happens automatically, and the feedback will persist. So if you, clear your plan cache or your server restarts or anything, that feedback should still be there in query store hints. Other questions now, Free?
Yes. Can we turn off CE feedback for some queries?
I don't think so. I don't think so. I think you can disable it on a database level, but I believe I will double check on that. Ree, can you? I'll post it.
Yes. Nope. I'll put it over in Slack, and you can follow up later. Okay. Are we able to manually add query hints in Query Store? For example, we test with CE feedback in dev and find some queries are consistently improved. So we want those to have these hints in production without turning CE feedback on.
So there is a way to apply query hints manually using Query Store hints. Yes. Can you apply the CE feedback hints? I don't know. I think you can. I think that was the other question too, Rhea, if that was one of the first questions. But I know that you can manually apply the hints. Yes, absolutely. And my intuition says that you should be able to apply the hint from any source. You saw in my example that we record the source of where the feedback came from, but that I think that's helpful for users to know. But if you apply it manually, that hint should still apply. But I will double check on that. I think that was also the other question I needed to follow up on from before. So
okay, so he has a follow-up question. Can I still force query plan with the plan guide mechanism?
If it's working for you now, I see no reason why it wouldn't. Is the question, when you force a plan, are the hints applied?
We can wait till he pops in.
Sorry.
To add clarity there.
It's hard to have a dialogue. I'm sorry.
I know. No, it's okay. So yeah, that's all he says is, can I still force query plan with the plan guide mechanism? So
okay. Yes,
you can circle back if you want to move forward. That's all the questions that we have right now.
Okay, sounds good. But that's basically all I have. I hope I didn't. Let's see. I guess I left some extra time. But I hope that was insightful and instructive, and that you all got something out of it. Thank you.
I think you broke us, Kate. I mean, in the best way, right? Look, Anthony. Look, Anthony's like, I thought, yeah. Look at Anthony.
I was trying to talk about your brains specifically. I wanted to build intuition.
So it's be careful what you wish for, I guess.
Yeah. No, that was great. That was great. I went ahead and updated the website so that your level is an 8192 instead of a 400.
We have to have a little chat about the levels, I guess.
So no, here's the thing. Here's what's important to know. To Kate, like this, all the algebra that, like the algebra rabbit hole that she took me down, which I did not sign up for the record. So she's just like, oh yeah, this is just easy. This is all that means. And we're all like, what?
I'm sorry.
Oh, hold on.
No, it was
I'm
good.
like,
It was fantastic.
No, it was
this is
fantastic.
Yeah, this
The-
is what
This
we
is
come here
this is
for,
exactly that type of session is exactly what EKB is all about. So thank you so much for coming in
But
and
Kate,
delivering that
Kate,
session.
you do have to go into Slack and like read the comments. And save that link for like when you have a bad day. Just go in there and people are like, wow, this is what?
We've already-
It's fantastic.
we've already
You gotta
had-
read it.
We've already had feedback coming in on the forums as well, and one of the comments is this is the best session ever. So
I'm already being read. Stop there. You guys stop.
Feedback was good enough that I've actually already sent a note to Ajay.
Oh, well, thank
I already sent a note to Ajay. So just so you're
Yeah, it's so valuable. I love when you started with the historical context of how we got where we are, and then like the behind the scenes perspective of like building this thing, and it's so valuable to the community, like what you delivered. So thank you.
Good. Well, yes, I actually have been around working in this space in a way that makes it's a perspective that is unique. Not everyone has that. So yeah, I'm happy to share it because it's really cool. It's really cool. I really like this stuff.
So Erin Stellato messaged me, by the way, and she says you can still use plan guides when you have QDS enabled, but you should not try to do plan guides and plan forcing on the same query. Just,
Okay.
I think that was in reference to an earlier question.
And I think if you're forcing a plan, I don't know that you get your pre-start hint, but I think that was I will double check, but I don't think you will. I think you'll just get what's in plan.
okay, so
Very
that
good.
is the end of
Well done.
AKB August. Oh, sorry. We are gonna wrap up, I think. Yeah, unless there's more. Is there any more questions? Any more comments? Anything?
No, we're good.
We all
and
good?
I don't see any. Yeah, I mean, I can
Awesome.
dig through.
No, we will. The Slack channel is always there. We keep that up. That's just constantly there during the year. So if you do have any questions, we do monitor it. So if you have questions for the speakers, please post them there, and we will forward them on. Now, the link again. Just repeating it again, please do leave feedback for the speakers and the overall event. We want to know what you liked, what you didn't like. Please let us know. The link is there. Go on there. It's only 4 questions and a comment box. Let us know. Thank you so much. And thank you so much for all attending. I want to say thank you all to our amazing speakers. We've had 5 amazing sessions. It's been absolutely fantastic. And I want to say thank you to all our moderators as well. Some of which have been here all day, helping out, making sure your questions get answered, monitoring the Slack channel, monitoring the Q&A in Zoom as well. They do a fantastic job allowing me, Anthony, and Mark to sort of make sure everything in the background is running smoothly, which is code for sitting here and basically just watching sessions. But thank you, and we will be back. We will see you all again. Thank you very much. Goodbye now.
Thanks, everybody.
Oh, wait, what button do I press? Oh. We're a professional operation here. We are a professional operation.
You're gonna edit that out though, right? I mean, what-
We leave it all
Probably
in.
not.
It's live.
Nice.
Here,
Oh,
I'll
Mark,
take over
yeah.
hosting.
You go, Mark. You know what you're doing.
Yep.
Fantastic job, gentlemen.